Good morning. My name is Mrs. Mendenhall and I teach 3rd grade at Chapel Glen Elementary. And today we are doing a lesson with Mr. Crosslin. So we're excited to learn about weather and heat.
Hey, thanks for that introduction. So today's lesson is about how heat is absorbed on our planet and how that helps us tell what the weather is. I don't know if you know, but today I listened to the radio and they said that the weather, they said these two numbers. It was going to be 21 degrees Fahrenheit and 32 degrees Fahrenheit. And I wondered why when we do the weather, do they always give two numbers? Does anybody know what that means?
I know it, Mr. Crosslin. It's the temperature in degrees.
I know it's the high temperature and the low temperature.
You are absolutely right. You guys are awesome. That's exactly right. So today when I heard the temperature 21 and 32, I knew it was going to be cold. This is what's called the low, and this is going to be the high. That means today it's not going to get very warm. So I like to listen to the weather and look at the patterns. That way I know what to wear when I go outside. Good thing I didn't wear my shorts and flip-flops today. Because it was cold, I had to wear my winter coat. But this is so weird. So the temperature each day, so sometimes during the day, here's a nice graph. Let's take a look at this graph. If I make a graph, this is start, and this is finish, right? Start and finish. The temperature starts out in the morning, kind of low, then it builds up, and then it goes down. And then the next day it builds up and goes down and builds up and goes down. What do you think causes the temperature to build up and to go down?
I know, because in the afternoon the sun's over us, and in the night the sun is behind us.
So those are some great answers. This class is well prepared. So if I made a model of this, there's the sun. The sun, when it's shining over the earth, when it's shining, it heats up the earth. But when the earth rotates around, no sunshine, no heat, it gets cold. When it rotates again, sunshine, heat, it gets warm. Come here, young man, let's show him what I mean. Bring that earth. Come on in. He's got the whole wide world in his hands. Here we go. So here's the earth. The earth is rotating. I'll hold it and you spin it. I'll hold it and spin it with one hand. Here's the sun, spin it, there you go. The sun is shining on it, stop. Right here, the sun's over the United States, but the earth rotates or spins. Go ahead, rotate some more. Now, it's over China, and our temperature should be cold, but who should be getting hot now? China. Rotate. Now China's cooling down. Africa. Now the Atlantic Ocean. It's morning time. Who's getting hot now? United States. Pacific. So go ahead and rotate. So the sun is in the sky. Keep rotating. And as the earth rotates, it heats it up and cools it down. That's a pattern. It's a weather pattern. We get hot and cold, high and low because of day and night. Wouldn't it be a weird world that we lived in, that it got hot at night and cold during the day?
Yes.
But it won't work because it's the sun that heats up the earth. Okay, so here's a map of the world. And now we know it's not the sun moving, it's actually the earth moving. But for our model, we're going to have the sun move across. But you notice it's not all the same. Parts of the earth is covered in what?
Water.
There's the Pacific Ocean, the Indian Ocean, the Atlantic Ocean, the Pacific Ocean. So as the sun comes across here, it heats it up different. Let me show you what I mean. So when it's dark, the earth is not getting heated up. But when the sun comes, and it takes 24 hours for it to go all rotate around. So every 24 hours, we see the sun coming over. And when it's exactly over us, that's where it gets the hottest. But as it goes, it cools down. And you notice that we have the ocean getting warm the land getting warm, the ocean getting warm, the land getting warm, the ocean getting warm. And here's my question. Do they heat up the same? What do you think? Okay, so I've set up some science stuff for us to test, all right? And so water and earth are different. So here is a cup of water, and here is a cup of water. And so what I'm trying to think, I wonder if they heat up the same. And so what you see right here is I've hooked up a light source, and I've been heating these up, and I noticed that the black and the white, or the water and the earth, are different. We'll just see how these heat up. So let's take a look at first over here. So I have, check this out. Here is soil and land. So here's soil. Would you turn on the soil? Let's see, is that one? Up, there's the land, and there's the water. And so we have two lights that are the same. This says, what does it say?
Soil land.
So if the sun is over the soil and land, we're going to see if that heats up. And what does this one say?
Water and ocean.
And so this is like the earth with the sun going across it. And so we've got these start to heat up. And while we're doing that, this is what we use on our planet to measure heat temperature. This is how much, what is this called?
A thermometer.
A thermometer. And somebody has a worksheet. Would you go give me your worksheet for a second? What's your worksheet? Yeah. So a thermometer, this is actually kind of interesting. This thermometer has two different scales. And it's kind of interesting that two different scientists worked on the thermometer at the same time. And so your teachers run off this scale right here of different thermometers. Would someone get me a red marker? You notice that we have, thank you, that we use a red, there's a red fluid in here, and when it gets hot, it expands. And since it's in a tube, when it gets hot, it expands. It only has one way to go. Which way do you think it goes? Up. And when it gets cold, guess what it does?
Goes down.
Goes down. Now, so this thermometer, you'll notice, we're going to do an experiment with these in a little bit. We color this in red. As it gets hot, it starts to go up. So right now on our land, our thermometer is going up. In our water, it's going up. But here's the cool part about it. I'm going to look at this thermometer right here, and we turn them on the same time, and that says it is 90 degrees. And this one says it is 80 degrees. A big difference. One says 90 degrees on the soil, and that is a degree Fahrenheit. And this one says 80 degrees Fahrenheit. Which one heats up quicker?
Soil.
So you can imagine when the sun is going across the earth, when it gets over the land, what happens to it? The land
Heats up.
quick, right?
Yep.
And then when it goes over the ocean, it heats up, but not as quick, slow. And here's the weird part about this. We'll leave this going because when the earth rotates around, guess which one gets cold quicker? What do you think?
Water.
Or it might be,
Soil.
or they might be the same. And I think you're going to be surprised at what we find out. I'm not going to tell you. We're going to look. So this one's getting hot quick. This one's getting hot slow. When we turn off the light, we're going to see if they keep their temperature. So this thermometer is kind of cool. So there's a thermometer, and there was two different people. There was a guy named Fahrenheit. Everybody say it, Fahrenheit.
Fahrenheit.
He made a thermometer, and there was a guy named Celsius.
Celsius.
They both made a thermometer, but they used a different scale. The Fahrenheit scale, when we have ice, you know, a chunk of ice, I'll make a little ice cube here. You know what ice is, right?
Yes.
It's when water freezes. Fahrenheit said, let's make water freeze at 32 degrees Fahrenheit. Now that's a kind of a weird number because Celsius said, nope, I'm going to say that water freezes on my scale at 0. Which is easier to remember, 0 or 32?
0.
So scientists and almost the whole world likes to use the Celsius scale because it's 0. It's easy to remember, right?
Yes.
So you might wonder, why did Fahrenheit start at 32? Well, here's what he did. At the time, he tried to make something as cold as he could. And what he did was he added salt into salt water, and it got really cold, and it froze. Salt water froze at 0 degrees. Salt water. So he thought, that must be the coldest something can be. I'm going to start that at 0. Regular water freezes at 32. So he made that 32. And guess what? Boiling, you know, boiling water, when you put water on a stove, water boils at 100. Guess who's scaled at 100? Who likes numbers like 100?
Fahrenheit.
No.
Celsius.
No. So Celsius says, water will boil at 100 degrees. And Fahrenheit, you know what his scale did?
A little higher.
212 degrees water boils. So when you go outside today, it's important to know which scale the weatherman uses here in Indiana. What do you think he uses?
Fahrenheit.
Fahrenheit. So when you hear like when they said it was going to be, you know, like 21 degrees or 32 degrees Fahrenheit, you know what that means. If they're using the Celsius scale, you need to know what that means too. So these two things that we're using, this one is 90 degrees Fahrenheit, 80 degrees Fahrenheit. This one got hot really quick. This one's slow. I'll tell you what, we'll turn off the lights on these two just for a second, and we'll see, and we'll check back at the end to see what the temperature is, okay? You ready for that? Let me turn that one off. Let me turn this one off. Now, what else could stop the sun from heating the earth? What else could block it? What do you think could block the sun? Yes?
If like
Something up in the sky? Like,
something blocks the sun from getting to the earth.
what would be those big things? Yes, class?
The moon.
Well, the moon would, but
clouds.
the clouds. Yeah, and so I see you guys made some awesome clouds. And so some of these clouds right here really block the sun. So if there's a lot of cumulus clouds in the sky, it might be kind of gray underneath, right? But what if there's some real thin cirrus clouds in the sky? That probably lets the sun go through, right?
Yep.
So clouds can affect how much sun comes to the earth. But I got another question for you. This one's kind of cool. If you wanted something to stay cold, for example, snow, what color should it be?
White.
White. Why white? Wonder why white? Yeah.
Because that's what the color of snow. The color is the snow and the clouds.
Isn't that interesting that clouds and snow is white? You have something to add to this? Why is snow white? I don't mean Snow White, you know, in the Seven Dwarfs. What if snow was a different color? What would happen? What do you think?
It will melt.
No? Well, let me show you. Check this out. You see, snow, let me ask you this. Which color is better at soaking up heat? White or black? Oh, well, I like it. We're not decided. We have white, we have black, right? So let's say here's my white snow, and here's my black snow. Would you put one of these on each hand right there? Put that on your hand? Now let's let her put both of those on right there, okay? On yet? Okay.
Like that.
All right, put them over the top of this. Put them together. Do you feel anything? No. All right, so we're going to do this for 10 seconds, and then touch them to your cheeks right now. 1, 2, 3. You feel anything? It feels the same. Let's see what happens. Let's see, how many people think that they're going to be the same when I heat them up? Okay. How many people think the white's going to get hotter? Okay. How many people think the black's going to get hotter? Let's find out. From like that, here we go for 10 seconds. 1, 2,
3, 4, 5, 6, 7, 8. They get hot.
Both of them got hot? Which one got hotter?
This one got hotter.
Yes!
Can you prove it? Let's do it for
I wanna do it.
let's do it for 5 seconds this time. Not so. Here we go. That hot, huh? And we'll do 5 seconds into your cheek. Right, here we go. 1, 2,
3, 4, 5.
Touch your cheek. Which
Hot.
one's the hottest?
This one still.
Wow.
This one's kind of hot.
But which one's the hottest? So which one do you think absorbed the heat and which one reflected the heat?
White reflected.
Let's see, let's get another man in here. Come over here. Over here, let's try this. So I have some water heating up here and here. Which one do you think is going to heat up the most?
The black one.
The black says it's 90 degrees and the white says it's 80 degrees.
Yes.
Just like that and that.
Just like that and that. So black absorbs heat. Let's prove it one more time. Ready? Put your hands together a little bit higher. If it gets way too hot, move your hands. There we go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Put them on your cheeks. What do you feel?
Black is hotter.
Okay. Which one?
Black.
Nice. Next.
Black.
4, 5. Test. Which one? Black. I think we proved that black absorbs more heat. Okay, so let's go back to this experiment about the water, ocean, soil, and land. They've been cooling for a long time. This one went way down. And this one now, let's see what these are. This one is at 80, and this one's at 75. So this one got hot really quick, but it got cool really quick. And this one got hot slow, but it got cold slow for cooling. So they heat unevenly. Hot quick, cold quick. Hot slow, cold slow. And so I think that has something to do with what we're going to learn in our next lesson about wind. But I'll tell you what, let's do a little bit of a thermometer safari. You want to try that?
Yes.
Okay, let me give you a thermometer and then go back to your seats. Take a thermometer and pass them out and we'll head back to your seats. Okay, so now we're back ready to do our thermometer safari. And everybody has a thermometer. We're not touching it because the heat from our hand might change it. So I'm glad everybody has them on their desk. So we need to come up with the room temperature. And these thermometers, we're going to do it in, today we're just going to look at degrees F for degrees Fahrenheit. Okay, and so the thermometer I have, it says the room temperature is 80 degrees Fahrenheit. Check your thermometer and your room temperature.
So that's 70.
And don't forget to write your degree and the F, right? You can write out the word degree or you could use the symbol. 80 degrees, and what does it look like? 80 degrees what? Celsius or Fahrenheit?
Fahrenheit.
Fahrenheit. Okay. And so everybody has marked down what room temperature is, yes?
Yes.
This is room temperature. I want you guys today to find 3 places in the room that are warmer than room temperature and 3 places in the room that are cooler than room temperature. Okay? And so I'm going to do one right now. We'll all take it. Hold your thermometer from the top and carefully put it under your armpit. Ready? Under your armpit. So I'm going to take mine out first. Leave yours in. Mine went up to
90?
degrees Fahrenheit. Go ahead and check yours.
Let's see how much I got then. Wow, that's a lot. 23.
So I want you to later to find 2 more places in your room that are warmer than room temperature. We found one, your armpit. What about some places that are colder than room temperature? Any ideas?
How about you look outside? It's snowing.
You're kidding me. What?
It's snowing.
It's snowing outside? If it's snowing, what must the temperature be at least?
14.
14. And, you're right. This is perfect. It's actually snowing outside, so it means it must be at least 32 degrees somewhere, because that precipitation is not coming down as rain, it's coming down as
Snow.
So probably you guys can go outside later with your teacher and check places that are cooler than room temperature. And what color is a good color for snow to be?
Why?
Why?
Because it's lighter.
It's lighter. Does it reflect or absorb heat? It
Reflects heat.
Nice. Hey guys, this has been a great lesson. I have one thing to say. You guys must be a hot class.